Morning everybody, welcome to Tuesday's Maths. We're nearly at the final part of this unit. So let's get warmed up first. So to begin with, I thought we'd have a little bit of a practice of some of our cubed and squared numbers. We haven't done this for a little while and it's quite relevant for what we're doing today. So remember, if you are calculating a cubed number, so for example, if I wanted to know what was 2 cubed, I would think, well, I've got to multiply 2 by itself 3 times. Let me switch my pen on so I can write it down to show you. So if I wanted to do 2 cubed, I would have to do 2 times 2 times 2. So remember, this little cube sign's telling you to multiply that number by itself 3 times. So the answer to this would be 2 times 2 is 4, times by 2 is 8. Now, what was the difference from 2 squared? Well, because now it's squared, we multiply it by itself just 2 times. So 2 times 2 is 4. So have a go at these following 4 questions, pause the video and then come back for some answers. Okay, so here we go then. 3 cubed and 2 cubed. Now 3 cubed is the same as 3 times 3 times 3, which is 27. And we've got to add 2 cubed, which we did at the beginning and was 8. So 27 add 8 would give us an answer of 35. Now for number 2, 5 cubed is 5 times 5 times 5, which gives us an answer of 125. And we're taking away 5 squared, which is 25. So that would give us an answer of 100. Now 6 squared is like 6 times 6, which gives us an answer of 36. And we're dividing that by 2 squared, which is 4. So that would give us an answer of 9. And then 3 squared, 3 times 3 is 9, and we're timesing it by 10 squared, which is 100. So it would give us an answer of 900. Hope you've all remembered how to do that. Okay, today's lesson then. We're looking at calculating the volume of a cuboid. So we're looking at 3D shapes now. So rather than doing area like we did last week, looking at 2D shapes, volume, we've got a little bit extra to look at. Now we need to be able to count all the cubes in a cuboid, first of all, to get us in the right thinking. Then we've got to use the correct units, and we need to be able to see the layers of the cubes within a 3D shape or a cuboid. So I'll discover them. Now Jamila and Max have both built 3D shapes, and Jamila has said my solid has a greater volume than yours. It takes up more space. Max is saying we're both using cubes that each have a volume of 1 centimetre squared. Now what does that mean? When we looked at area last week, we were looking at 2D shapes, rectangles that were flat on our piece of paper. So to work out the area, we just multiplied the length times the width. Now, when we're looking at volume, the difference is that we have got a 3D shape. So we have to take that into account when we're working out the area of that volume. How much does it go inside? So we need to also think about the depth. So when we look at this 1 centimetre cubed here, we have got on this cube, we've got its width, haven't we? We've got its length, 1 times 1, but also we need to think about its depth. So how far back it goes. So if we were to put it into a container, how deep would that container need to be? Now we're looking to see, is Jamila correct? So does her solid have the greater volume than Max's? Let's have a look. So here are both their shapes. Now, the important thing when you're looking at volume is that when we're calculating how many cubes are there, that we have to consider the cubes that we cannot see. So for example, if we look at Jamila's shape, cubes that we can see, I'm just going to put a dot on the top of them. 1, 2, 3, 4, 5, 6. We can see those cubes, can't we? And maybe some people would say, oh, there's one here, look, 2, 7. But if you look at it like this, you can see that the bottom part of the shape would on its own have 6 cubes. Can you see? 1, 2, 3, 4, 5, 6. So actually this one here, you can't really see in the original diagram, but it is there because it is holding up this cube just here, okay? Now, when we are thinking about how to calculate the volume, it's a good idea to think of them as layers, all right? So this is like the bottom layer. And you could think, well, here's my width. I've got 2, 1, 2 going across, and I've got 1, 2, 3, 1, 2, 3 in the depth. So this here is the same as saying 2 times by 3. So this volume is 6 centimetres cubed. And then on top of that, we would stick the next 2 cubes. So this one here has got a volume of 2 centimetres cubed there. So to find the total volume of the shape, we would add them together. So this one has got a volume of 8 centimetres cubed. Now note the difference as well from when we did area, we were talking about centimetres squared. Now with volume, we're thinking of centimetres cubed, because really we're looking at the length, the width and the depth. So there's 3 different parts to the shape we're looking at. Now how about the cube that Max built? Now we can see by this diagram, look, that there's 2 layers. So really if we look at, I always look at the top layer for these ones where it's completely filled on the top and the bottom. And I would think, right, well look, I've got 1, 2 going across, and I've got 1, 2 going backwards. So for the top layer, it's like 2 times 2, which is 4 centimetres cubed. Now I've got 2 lots of those, so then I need to times my 4 centimetres cubed by 2, because it's 2 lots of the same. And so look at that. In fact, this 3D shape has the same volume of 8 centimetres cubed, because we could count them all. We've got 1, 2, 3, 4, 5, 6, 7, 8 cubes in there. So it shows you when you separate them like this, how important it is to consider the hidden cubes that you can't see, because they are still part of that shape's volume. Now, obviously, if we were in school, we would have a practice with these and we would build them and it'd be a lot easier to see. So when you're doing these, I really want you to imagine that you're building with cubes and putting them together, because that will help you to think about which ones are underneath. The next part is just showing how Jamila has calculated it, very similar to how I've done. Now, on the think together, we've now got to look at how to calculate the volume of each of these solids. Now, I think what's a good idea here is if you pause the video and have a go yourself and think about which cubes are hidden, what are the volumes you get, and then come back and go through the answers with me. All right, so number 1A is quite straightforward because there aren't any hidden cubes here, but we can see along the bottom we've got 1, 2, 3, 4 cubes along the bottom. Then we've got 2 rows of 2 cubes. So we've got another set here. So we've got 1, 2, 3, 4. So in total here, we've got a volume of 8 centimetres cubed. So if we can just count the cubes, we can see. Now, for part B, we can see 1, 2, 3 cubes at the front, can't we? And then we can see another 3 cubes along the top. So at the moment there, we've got 6 centimetre cubed, but also these 3 cubes here along the top must be sitting on 3 cubes underneath, because they can't just float, can they? So that must mean there are another 3 cubes under there, which would take us to 9 cubes. And then we've got 10, because we've got this one here, and 11 here. So actually the volume of this one is 11 centimetres cubed. Now, this is a classic one where there are hidden ones. I always think, well, if we were to take off this row that we were looking at, underneath would be 3 more. So you've got to include that into your calculation. Now, finally, then for C, I would separate these in my mind into layers. And let's look at the bottom layer first. So you can see here across the width, we've got 1, 2, 3, 4, 5, and then the depth going back 1, 2, 3, 4 going back. So we've got 5 times 4, which is 20 centimetres cubed across the bottom. Now, stuck onto the top, we could just count them, or we could think, well, there's 1, 2 across the width, and then 1, 2, 3, 4 going down the length. So 2 times 4, that's got a total of 8 centimetres cubed. So we now just need to add those totals for the 2 layers together, and that will give us this one, 28 centimetres cubed. Okay, now these ones here that we're looking at are looking at the cuboids. This first one has put them into 2 colours so you can see the 2 layers, and then it's split them. Now, what it wants you to start thinking about is how we calculate volume using a little bit of a formula. So you can see here that I always look at the top layer first when they are the same on the top and the bottom. So I would think I've got 1, 2 going across the width, and then going across the length, I've got 1, 2, 3, 4, 5 cubes. So to work out the top layer, you can see here, it's done 2 times 5. And then I put my answer in here. So that is 10 centimetres cubed for one layer of our cuboid. Now, because we've then got another layer, so this is like layer 1, we've got a second layer, which is exactly the same, it's identical. So we just need to multiply that 10 by 2, because we've done the first part already, we don't need to repeat it. So that gives us a final volume of 20 centimetres cubed. The whole volume has a final, the whole cuboid has a final volume of 20 cubic centimetres. All right, have a look at this one. Work it out in the same way. Now, because we can't really see the yellow layer, but it's matching to the blue, we can see that they fit on top of one another. We can count down the width. We've got 1, 2, 3. So we've got to do 3. How many across the length? 1, 2, 3, 4. So we're doing 3 times by 4. Now, the answer to this, we're going to put in this box. 3 times 4 is 12. Now, how many layers have we got? Here is layer 1, here is layer 2. So we've got to multiply that by 2. So 12 times 2 gives us an answer of 24. So the volume of the cuboid is 24 centimetre cubed. So do you see how I've worked this out? That this first part here is the measurement for one layer, and I've put the answer to that here, okay? And then I thought, well, how many layers have I got? And I've multiplied the answer to that first part by 2. All right. Okay, so your work today, you're going to be working in your Power Maths books, volume of a cuboid 1. You're going to be working on pages 144 to 146, and a lot of the work that you're doing today is going to be looking at counting the cubes, can you split the layers, multiplying them together, and seeing how you can work out the volume in quite a visual way. If you finish all that work and want to have a go at the challenge, here it is for you to have a go at. Good luck, and I'll see you tomorrow. Bye-bye.